one.
Yeah.
There, I'm recording it now, so we can send that to him, see if that'll help him.
Okay.
That way he can figure out our reasoning behind things too. I think that maybe that'll be easier for him. I don't know.
No, definitely. I'll let him know. Okay. Wouldn't it be right skewed still?
Suppose the sample size of the study was 2. It would be right skewed. You're right.
Because it has to
there's
be
only
more
2.
than 30, right?
Pretty much. I mean, it just has to be significantly bigger, and that's not.
Yeah.
If they stuck with n equals 70, it would be normal.
Yeah.
All right, so on number 8, we do that normal thing to find the z-score, I think.
Okay.
But you do it where you divide it by the square root of n.
Oh, yeah.
So 8550 minus 8544 divided by 12 divided by the square root of 20.
Yeah.
So I got 2.236.
Yep, me too. 2.236.
I feel like we had that same question a couple months ago.
Oh, really?
I think so.
That's all we have to find is the z-score, right? Yep. So on 9, how do we go about doing that one? I don't even remember.
So it wants the probability, so we need to do find the z-score and then put it into the applet.
So it will be greater than 8,540? So how are you doing the z-score for this?
So you find the z-score for 8,540 and shade everything to the right of it, above it. You get what I'm saying?
No. So
you figure out what your z-score that corresponds to 8,540.
Yeah, but how do you?
Then you put that into your applet as what your number will be, and it'll be a negative. It'll be a negative z-score, and you shade everything to the right of it.
Okay, but for the z-score, don't we have to have like a new number to calculate it?
No, so we still use the mean of 8,544. So you do 8,540 minus the mean that we got up there.
Questions 8 and 9. I thought number 9 was by itself. I was like, I'm missing stuff. I don't get it.
No, yeah, we're still corresponding up from the previous one.
All right.
That make more sense?
That makes way more sense. Man.
Bless you.
Thanks. So we're going to shade everything to the right of it, right?
Yeah, so your z-score, I got negative 2.357.
Yep, that's what I got too.
So it should be 99. So to 3, so 0.991.
2.2. You said negative 2.237?
Yeah, negative 2.357.
Oh, whoa. I didn't get that.
What'd you get?
Negative 2.236. Were you rounding before?
No, I didn't.
Huh.
At least I try not to. My calculator fought me, so I tried not to round anything.
Yeah. Weird. Let me try that again. So let's just see if I did it right. Did you do 8,540 minus 8,550 divided by 12 divided by the square root of 20?
No, you do 8,540 minus 8,544.
Oh.
The 8,550 was from the previous example, but the mean's still 8,544.
Ah. Mean. Oops, yeah, that's where I went wrong.
So yeah, it should be negative 2.357 is your z-score.
Okay, let's see here. What in the world? Okay, so you did 8,540 minus 8,544
Uh-huh.
divided by 12 divided by the square root of 20, correct?
Yes. And that should give you negative 2.357 and 0, 1, something, something.
Yeah, I don't know what I did wrong again. Now I'm way off. Weird.
Yeah, I'm not sure.
Let's try it differently. Yeah, I don't know what I did wrong. I'm just way off right now. So you got, what did you get? Negative 2.
Negative 2.357 is the z-score.
And that will give us,
The final answer would be 0.991. Because when you put that in and shade to the right, it gives you 0.9908. So 991 is the answer.
so you did 0.991.
Yeah.
Okay. Cool.
All right. So it's 10C.
Yeah, yes. Or is it? So I remember on our last one, there was a question just like this.
Yes, I remember too, and I can't remember if it's either C or D.
I'm gonna look it up real quick.
Okay, so on the last one, I selected C, and I got it wrong.
So I think it's actually committing a type 1 error.
Oh, is that what it is?
Well, I mean, do you remember what lesson that was?
In the prep for last quiz, in the prep for last test in week 10, lesson 20, the group meeting, it's number 9 is the question.
Details, okay. Yeah, it's the probability of committing a type 1 error.
Okay.
Yeah, I remember because we went to the tutor and she was helping us out on that one.
All right.
We were like, oh.
I like it.
Yeah.
So on number 11, it's not the first box because it says chance.
Yeah.
I think B would be one of them, right?
Yeah, that's what I was thinking. B and C, I remember C being one, approximately 95% of all 95% confidence intervals, which is weird, but
Yeah, that's just phrased really weird.
let's see here. Yeah. So Yeah, like on the last preparation assignment, number 11, 95% of all 95% confidence intervals actually contain the true mean. So there's that one.
It won't be D.
So you don't think it'd be B?
Oh no, D is in dog.
Oh, D. Okay.
Would it be E, the last one? Would that count? 95% of heights of female adults in our sample are in the confidence interval.
I don't know. That'd be a good guess. Because that one sounds correct.
And because it says in the sample, it's not saying everyone.
Yeah.
So I think that's one of them too.
Okay. We know that 95%, so like B, we are 95% confident that the true mean, so we know that one of them is the true mean, but I don't know about sample mean. So it must be. If the true means it, then obviously the sample means it too, right?
Yeah, well, yeah, I think it's pretty much saying the same thing. 95% of the heights of female adults in our sample. So 95% of the heights of female adults in the sample are in our confidence interval. So it's saying 95% of the women in the sample are within this range.
Okay.
I think.
That makes sense though.
So I think it's B, C, and E.
B, C, and E. Yep, that's what I put. So we'll find out.
Yeah, we can take it again too.
Good point.
Are you leaving? Okay. I'll see you after my meeting. Okay. Love you. Bye.
So I'm gonna read you the requirements. You tell me if there is one. Is the sample a simple random sample?
Mm-hmm.
Is the
Yes.
population standard deviation known?
Yes.
Okay. What about a population is normally distributed, or the sample size is
It's normally
larger?
distributed.
Okay. And then I think
I think it's A. It says yes, the distribution of sample means is normal because the data is normal, and they use this random sample, and it follows a normal distribution. Because B doesn't really matter if it's the sample size is large because it's a
it's
simple
already
random sample with a normal distribution. So who cares about how big the sample size is because
yeah,
it's already met.
exactly.
So we have to open up thing for this one.
Oh, yeah.
Oh, I gotta hurry and let my dog in 1 second.
All right.
I'm coming, Maggles. Come on, Tinker. Get in here. Watch out.
I'm pulling it up right now. Got it connect.
Yeah, mine's going super slow. I know we've had the same question before, so I'm sure it's somewhere in what we've done.
Yeah.
There we go.
Did you see the thread that was made for BYU Idaho?
I saw that, and I saw that they figured out who made the thread on that whatever app it is.
Yeah.
Crazy.
Yeah. Very, very crazy.
Makes you wonder what they're thinking.
It'll probably end up in BHC.
Yep. With crazies.
Okay. What is this one called again that we're looking up?
Rates of return.
Rates of return. Okay, so we're trying to find what is the p-value for this test. P-value. So we got to find the z-score, right?
Well, there's a way to do it with SPSS where you just run it through, and I can't remember exactly how you do that.
So what is the p-value? Isn't that our probability?
Yeah.
Okay.
Oh, so this is when we do the one sample t-test.
Okay.
Because we don't know, or do we know sigma? I don't know.
Says I don't think so.
No, that's not it.
So I think it is just we got to get the z-score, right? And then we just shade to, oh no. Hmm.
Question is how do you get the p-value using SPSS?
So,
Or wait, do we even have to use SPSS?
I did
Oh, yeah. Oh, yeah, you do. I remember how to do it, I think. So you have to figure out what his average was. So you
So
go
it
to
wasn't the SIG like if we? So you don't think it's a T test?
no, it's not. I think you're absolutely right. So you have to figure out what his mean income is or his mean return. Does it give us the rest of the information?
So the mean is negative 1.11. Is that what you're looking for?
Yeah, so it'd be negative 1.107 if you round it to 3.
Okay. And then what we got to do with that?
So I'm not sure. I thought I was on a roll, but I'm not. Thought I was onto something.
Hmm.
So this part is lesson 9, talking about the one mean. So you have to do it with his mean return. But does it give us the standard deviation?
I didn't see it.
S&P has a known population mean return of 0.95, but yeah, there's no standard deviation. So maybe it's not less than 9, it's less than 11, then covers one mean, sigma unknown.
Yeah. Isn't that a t-test?
Yeah, it is. So I was right.
Yeah, so I think all you got to do is just do one sample t. That gives you your your sig for a two-tailed, but this is just a one-tailed test, isn't it? But even then, your p-value is going to be higher than 0.05. So I think it's, what did you get?
So if you do the t-test, it gives you negative 1.152. Oh, and the sig is, yeah, so the two-tail test is 0.257.
Yeah. Do we divide that in half?
Well, what kind of, yeah, that you've got the right question. Is it a greater than, less than?
I think they want to know if they made less than. So that means it'd be a one-tailed, right?
Yeah, I think so.
So then his p-value would be 0.128, correct? Oh, 129. Right?
Yeah, I think so.
Okay, cool. Well, if that's wrong, I'm sorry, but
Oh, if it's wrong, it's wrong. I don't really care.
okay. 14. You got to leave by 9:30, or do you need to?
Yeah, I need to be done about 9:15.
Okay. So we got a little bit. We can go as long as we can, and then we can just email each other the answers. And
Yeah, and then I'll be at the hospital for a meeting till like 1 something. Then I have to leave for Utah by 4. So
okay. I've got a crap load of other homework, so I might put this on the back burner a little bit, just because I have so much nursing stuff to get done. But
yeah,
I'll have it done and email you, especially since we can take it twice. That's a good thing.
definitely.
So.
So this is dependent. I remember we've had this question. I feel like we've had all these questions before at one point.
Yeah, is it dependent? Because they do depend on each other, or no?
So it is a dependent one, and it's the last one. He needs to select couples for his sampling. So whether a particular wife is included depends on whether her husband is included. Because it's dependent on husband and wife.
Good point.
So I think we probably will be able to get at least to question 20. So we'll have half of it done almost.
Yeah.
Funny thing about this question is my roommates, when I was up at college before I got married, his sister-in-law's name was Allie Henrich.
Really?
Yeah.
Maybe it's her.
It might be. I don't know what her major was, but so another data file.
Hmm. What is this one called?
So this is a paired test, whatever the paired one's called.
But what
Oh, the file, direct flight cost. Sorry.
No, you're fine. You just gotta find p-value for this one too. So this is a paired.
Yeah.
So we do the 14 days, yeah, and the 90 days.
Yeah, it would end up being 14 days minus 90 days, I think.
Yeah. And then our T, or not T, SIG is 0.96. That's a two-tailed. What are we trying to figure out?
So depend on which way you can do the paired sample t-test or oh yeah.
Oh yeah, I do it different than yours. You did it I mean, it comes up with the same answer, but so a difference. So this one's just a two sampled because it's more or two-tailed. I mean, right?
Yeah, because they're just looking for the difference.
Yeah. So a 0.96. I mean 0.096. Is that what you got?
My computer's going so slow.
Oh, you're fine.
So what did you get?
I got 0.096 for a two-tailed p-value.
That's what I got too.
Okay. What is our? Oh yeah. So no. P-value was greater than level significance.
Yep.
For 16. Do you have any idea on 17?
So this would be a confidence interval using paired means, which I've got right here. So let me find the requirements here.
So it says that the plots were roughly from a straight line. Wouldn't that mean that it's normally distributed?
I think so. And the other requirements are simple random sample, or the mean of the differences is normally distributed. So I think, yeah, they met the requirements.
So would you think B?
I think so.
Okay. Ooh.
I think it's B.
I don't think it'd be B.
No, it's A.
It's either A or C.
Here, I've got it pulled up. Let me hurry and find how they word it.
Okay.
Let's see. They got to have it here somewhere.
So they want to know the mean of what? It's got to be.
Because they're just comparing the two, and they want to make sure that the two are equal.
Yeah, so it's got to be A. You're right.
But, oh, maybe not. I think it's actually C.
Is it?
Because at least, so this is discussed in lesson 12, and it says, state the null and alternative hypothesis and level of significance, and its HO is UD equals 0. And alternative is UD is less than or whatever to 0.
Okay. What?
But is this, am I under paired? 2 means paired data. Yeah.
Interesting. All right.
Yeah, I don't know.
Sounds good.
See if there's any other ones I can see roaming around. Yeah, it's because that's all it talks about is the UD. So I guess it is C.
Okay, cool.
All right, whatever.
Sounds groovy. 19, I would highly recommend B.
Sounds good to me.
Okay. T equals 4. What is this number? Five. I don't remember this one very good. Is it 50 or is it 5?
What is the smallest value of n to satisfy the requirements for a p hat? I don't remember this one super well either.
I'm trying to remember if it was times by 2 or times by 10. I mean, I think it might be 50 if I'm remembering right. I have no idea where that would be at though in lessons.
It was under exam 3, I know.
Was it?
I think so. Matter of fact, I'm pretty sure it is because it's a categorical thing. Yeah, so it starts talking about p hat in lesson 16. Anyways, I probably need to jump off though.
Okay, sounds good.
I need to leave here in 10 to 15 minutes for the hospital. So,
okay, yeah, no problem. Thanks for meeting with us though.
yeah, man.
Try to figure this out and I'll email you afterward. I'm gonna try to do my other homework first though. So
Sounds good. And then I'll hurry and try and see if it'll give me a link. Sometimes it fights a little bit giving the link, and I'll email it to Joe.
okay, sounds good.
All right, man. Take it easy.
Okay, you too. Have fun at work.
Oh, I will. Bye.
Okay.